further reinforce what we know about equilibrium systems, we've enlisted the help of Dr. Peter Mahaffey, and he's going to explain to us more about the equilibrium system involving hydrogen iodide.
Sure, let's take a closer look at the equilibrium reaction between hydrogen gas, which is colorless, and iodine gas, which is violet, and they react together to give hydrogen iodide, which is also colorless.
So, Dr. Mahaffey, we see in this equilibrium system that the product and the reactants are all gas.
That's right, and whenever we have a chemical equilibrium like this, where everything is present in the same phase, we refer to that as a homogeneous equilibrium.
So how would this homogeneous equilibrium system be established?
A mixture of hydrogen gas and iodine gas could be heated, and they would react together in a formation reaction to give hydrogen iodide. The concentration of hydrogen iodide gas initially is 0, but as the temperature gets above 425 degrees Celsius, hydrogen iodide becomes unstable, and it begins to decompose to give back hydrogen gas and iodine gas. If you start with hydrogen gas and iodine gas, the rate of the formation reaction initially is very rapid. Can you tell me why?
Well, because the concentration of the hydrogen iodide would be 0 at that point, and the concentrations of the iodine and the hydrogen gas would be very high. There would be a lot of molecular collisions, and the formation reaction would be very rapid.
And as the reaction proceeds,
the concentration of the hydrogen iodide would increase, and the formation reaction would slow down.
That's right. What can you tell me about the rate of the decomposition reaction?
Well, as the concentration of the hydrogen iodide increases, and you mentioned that a certain temperature becomes unstable, it begins to decompose into the two reactants.
So we have a formation reaction, which is initially very rapid and slows down, and a decomposition reaction, which is initially very slow and speeds up.
So at some point the two rates become equal, and at that point the concentrations are fixed.
That's right, and at that point we have equilibrium. As long as the number of hydrogen atoms and iodine atoms and the temperature are the same, we'll end up with the same equilibrium mixture regardless of whether we start with hydrogen and iodine or whether we start with hydrogen iodide.